Far away, Chris.
Thanks, Pete. And hello, everyone. I should check. Can you all hear me? Just if I see a few thumbs up, then I wouldn't worry. Great. That's fantastic. So thanks so much for letting me talk to you tonight. My day job is that I run something called the Committee on Climate Change, which is the body that was set up to assess the progress that the UK is making on climate change. But it means that I often deal with very technical topics, and my job tonight is to not be technical and to be as simple as I can with you about what climate change is. So I'm going to try my best to do that. This is an introduction to climate change. It's a massive topic, but my belief is it's made far too complicated very often. At the core of it, I think there are a few very simple things happening with some very obvious implications. And I very much hope you'll agree with that after my talk. So what I'm going to try to do tonight is to cover three things with you. First, I want to give you an introduction, very brief introduction to the science, the reason that we have this problem, and the thing that we're trying to tackle. Second, I want to try and explain what we mean by climate change and the impacts that it's actually having. And third, I'm going to give you a very brief summary of the steps that I think we can take to tackle climate change. I'm not going to try and lead you in that. I'm just going to give you a very brief intro on it at this stage. Everything you hear from me tonight is backed by very well-reviewed science. Obviously, really happy to talk about any of that after the talk if you're keen. But if you're happy with that, I'm going to start then with this thing that we sometimes call global warming and give a kind of a simple introduction to some of the science here. And I'm going to start by talking about our planet. So around our planet, if you can imagine, there's a layer of gases which we call the atmosphere. Now, if the Earth was an apple, the atmosphere would be about as thin as the skin of that apple. And it's those gases that protect the Earth's surface from the harmful rays of the sun. It also contains the oxygen that we breathe. It's the reason why there's life here on the planet. That atmosphere is made up mostly of the gases nitrogen and oxygen, but it also contains small amounts of some other gases. And some of these are what we call the greenhouse gases. That's things like carbon dioxide, methane, nitrous oxide, and also water vapor. It's those greenhouse gases that we need to understand a bit more about. So to do that, I want to talk briefly about how our planet stays warm. So the sun shines on the planet, and that warms the surface of the Earth. And heat then radiates back from the surface. And we know, because scientists have shown very conclusively, that those greenhouse gases I talked about trap some of that heat in the atmosphere. Now, over the history of the Earth, that greenhouse effect, as it's sometimes called, is actually what's helped keep the planet warm enough for life here on the planet. But we also know that in recent years, the concentration of those greenhouse gases in the atmosphere has increased quite rapidly, and particularly the concentration of one of those gases, and that's carbon dioxide. And you often hear people talk about carbon. That's what we're referring to, carbon dioxide. That very recent increase in carbon dioxide has been caused mainly by the burning of coal, of oil, and natural gas. And we sometimes call those things the fossil fuels. So around the world, fossil fuels have come to be used by people as a really useful, incredibly helpful fuel for things like transport, for generating electricity. They also keep us warm in our homes when they're burned. They're used a bit in industry as well. So fossil fuels, actually, they're really the basis of the modern economy. And that's not the only reason why the concentration of carbon dioxide has been increasing. It's also, there's also an issue with the way that we've been clearing forest land around the world. That has also helped contribute to changes in the atmosphere. So trees actually absorb carbon dioxide when they grow, and they release gas if they're cut down and burned or left to rot. So we have a brilliant historical record of how much that's been changing from some sampling that we've done recently in the air. So we've been doing that for over 100 years now. We also have sampling from tiny air bubbles that we can take out of the ice at the north and south polar ice caps, and we can look at the air in the bubbles, and we can look back over the historical record really of what the air was like over thousands and thousands of years. And if you do that, what you can see is that carbon dioxide has been increasing quite rapidly in the last 200 years or so. So if you look at a historical record of the atmosphere in the last 200 years, and particularly in the last 50 years, it's really started growing to the point where it's actually now about 1.5 times the level it was before we had the Industrial Revolution, when we really started to burn fossil fuels. And in fact, we haven't been at these kind of concentrations for millions of years. So the more carbon dioxide there is in our atmosphere, the more heat that is trapped in the air, and the hotter the Earth becomes. And that is the process that we know as global warming. And that's really what we mean by the rising global temperatures across lands and oceans. We can look at how much global temperatures have increased. And we know that the temperature of the air at the planet's surface has been rising, especially over the last 50 years. We know that through the records of thousands of weather stations across the world. We have satellite data, ocean data as well from ships and from buoys. And if you look at that data, we see that the global surface temperature on average over the decades 2006 to 2015 was the hottest recorded since we began recording it at all in the 1850s. Currently, the temperature is increasing at about 0.2 degrees centigrade a decade. And in recent years, we think that the temperature here on the surface of the planet has reached about 1 degree centigrade above what it was in the second half of the 19th century, so in the 1850s and beyond. Here in the UK, it's a bit more than that, 1.2 degrees centigrade. Now, that might not sound a lot, but it's actually quite a big change for the planet, and especially in the time over which it's happened. So to give you a sense of that 1 degree centigrade, if you think back to the Ice Age, many of you have heard of the Ice Age. The last time we had an ice age was over 20,000 years ago in Europe. At that point, we had ice in Northern Europe and large parts of North America. At that point, the global temperature was about 4, 5, 6 degrees colder than it is today. So to give you a sense of that 1 degree change, that's quite a lot actually in the history of the planet.
Thank you very much.
Pretty
Melanie.
significant, and especially over
Melanie
just 150
and Adam,
years.
you can leave us
Some
now and
areas
then
of the
maybe
world are
come
getting
back
warmer
in
a
10
bit
minutes.
faster than
Well,
others. If you look at the Arctic, for example, that's warming faster than other parts of the planet. That's sitting more like 2 degrees warmer than it was 150 years ago. Occasionally we hear that that's just part of the normal cycle of the planet, and it's true that the planet has warmed and cooled over millions of years of its history. But we know, because scientists have spent a long time looking at that, if you look at the host of factors that might affect the global temperature, including things like the strength of the sun, for example, then we have a high confidence that practically all of that recent warming is due to human actions, basically those things that have increased those greenhouse gas concentrations in the atmosphere. So that's global warming, and that's the main cause of what we call climate change. So next, I'd like to talk about climate change. When I talk about climate change, what I'm referring to is a change in the average of the things that define our weather. So what I mean by that is things like the temperature, rainfall, wind patterns, how humid it is. Climate change is a sort of shorthand for changes in the severity of those weather conditions, or the frequency of those weather conditions. Throughout Earth's history, that has changed. So it's come in cycles. The climate does change in cycles. That happens over very long periods of time. We have a good record of that, and that's a natural process. Climate change refers to the much more rapid changes in the climate that we've seen over the last 50 years or so. And the scientific evidence is very, very clear that these changes are not being driven by those long-term climate cycles. Instead, the main cause of global warming is really the human activities that we can say with certainty are causing it. Now, why is all of that a problem? I mean, everyone loves a nice hot day. So I think it's important to talk, not just about warming, but what impacts come from that kind of climate change. And they are pretty profound. So pretty big changes in the natural world, and also in the conditions that we live in on the planet. So without being alarmist, I'll just give you a sense of that. And I've picked out 5 of the biggest impacts of climate change that we are already seeing. So just at that 1 degree of warming that I've just talked about. First is increased rainfall. So warmer air actually holds more water. So we get heavier downpours. They're more likely as the temperatures increase. That increased rainfall can lead to increased flooding, which of course damages properties, can threaten lives. In the UK, we have pretty good evidence that specific weather events, there was the one in the winter of 2014 and 15, where we had really heavy rainfall, that was made much more likely by climate change. And you see similar impacts around the world. Hurricane Harvey is one of the most famous events. If you work in my field, that was in Houston in 2017. Scientists look very carefully at that. That's the second most costly hurricane ever to hit the United States of America. climate change made that much more damaging as a downpour, about 3 times more likely that those kind of things will happen in the future, rather now that we have climate change than in the past. So that first one is about increased rainfall. Second is about heat. So it changes in extreme heat. So we have higher average temperatures now, and we now have higher average temperatures more frequently. We have higher temperatures more frequently. So some of the extreme heat waves that we have experienced here in the UK and around the world, they are now happening more frequently. The increased temperatures also make events like forest fires more likely. We saw that in Australia more recently. Parts of the world, because of those increased temperatures, are also seeing more frequent and more extreme droughts. So that's heat. Thirdly is about the availability of food, fresh water. The changing weather that I talked about has actually affected crop yields around the world. That's the quantity of crops like wheat, like maize that can be produced from an area of land. In some areas of the world, climate change has actually helped that go up. So we're producing more from a patch of land than we used to. But overall, if we look at the world, those yields from that land, the amount that can be produced from it, hasn't risen nearly as fast as it might have done without the effects of climate change. So it's affecting the amount of food that we can produce. And the other thing that it's affecting is the availability of water for drinking and for farming. That's particularly where we're downstream, where parts of the world are downstream from glaciers. So in areas like the Alps, for example, a really important source of drinking water is being affected now by the fact that the planet is warming. We think that drinking water is an issue for a third of the global population, where they're near glaciers. So this is a real challenge overall. Fourth is rising sea levels. So the higher air temperatures that we've seen are causing increased melting of what we call the ice sheets in Antarctica and Greenland, these huge sheets of ice that run off into the oceans. And the other thing that's happening is the planet is warming, and that's causing an expansion of seawater. So think about, it's a bit like the liquid inside a thermometer. When it's warmed up, it expands. So it's the same thing that happens with the sea. Both of those things are now driving an increase in global sea levels. The sea level around the world has risen already by around 20 centimeters, which again might not sound a lot, but when you have a storm surge, that makes it more likely that we see sea defenses overcome more flooding. And fifth is about nature. So we know that in the seas and the oceans, that increased temperature has led to warmer water. That puts pressure on the things that live there. So quite famously, the Great Barrier Reef is a coral that it's in quite shallow water. It's recently declined by up to 50% because the water was so warm in these extreme heat events I talked about. And that's a more likely thing to happen in today's climate than it was in the past. So that's the sort of thing that's already happened. What about the future impacts? So just a quick recap, just what we've talked about. Global warming is about driving climate change. Global warming is being driven by the increased concentration of greenhouse gases in the atmosphere. And the prime culprit for that is carbon dioxide, which is produced when we burn those fossil fuels. Much of the carbon dioxide we've already emitted is going to be in our atmosphere for centuries. Some of it's going to be there for thousands of years. So the more that we add to it, the more the concentration of carbon dioxide and the other greenhouse gases increases, the more the planet becomes hotter. And that's what's happening now. So when we look into the future, that's the thing that we're worrying about. So as the world warms, the impacts of climate change become stronger, they become clearer. We have more frequent heat waves, declining availability of water in some regions, many of them already dry today, quite substantial risk to the diversity of animals and plants that we have around the world. And it's the consequences of those impacts, the possibility that we might see the need to migrate people around the world to escape those impacts. That's what's led to the effort to do something about all this and to try and halt the global warming I talked about, and to tackle the causes of that global warming. So this is the last section. I just want to talk about what we can do about all of this. So the question is, can we stop climate change? And there's a very simple thing to say in response to that question. And this is as much science really as you need to know, I suppose, to answer that question. Very simply, the planet only stops warming when we stop adding to the concentration of carbon dioxide in the Earth's atmosphere. So that means reducing the global greenhouse gas that's being produced, those what we call emissions, to a much, much lower level than they are today. And then trying to balance off any of the remaining emissions by finding ways to absorb some of it from the atmosphere. So let me just briefly explain what that actually means. That means moving away as much as we can as a society around the world from the things that are causing those greenhouse gas emissions that I talked about as much as we can. So that's burning coal, for example, to generate electricity. It's about burning natural gas to heat our homes, driving less perhaps, cycling, walking more, phasing out entirely cars that use petrol and diesel. Those are a really important source of emissions, especially here in the UK. Might mean flying less in airplanes that burn jet fuel. It could even mean things like changing our diets, so eating fewer cows and sheep, which themselves cause greenhouse gases. So those are all kind of useful strategies, and there are many more we could talk about for reducing the amount of greenhouse gases that we have in our atmosphere. And we also need to look for ways that can absorb carbon dioxide from the atmosphere, lock it away safely so it's not causing global warming. I mentioned before, carbon dioxide is absorbed when we grow trees and when we grow plants, for example. So that's a good strategy for netting off overall the amount that we're producing.
And 4 minutes left, Chris.
That's fine, I'm nearly there. Just Pete, 1 more minute actually. The basic rule is the more rapidly we reduce those emissions, the more we minimize the further changes in our climate. Now, several countries around the world, including here in the UK, have signed up to a global goal to do something about that. The United Nations tries to organise the global effort to cut those emissions. That's what I work on, so advising on how the UK as a whole can get to what they call net zero emissions, which is the point where you've got to the overall position of there being zero emissions overall. So, in a sense, you are no longer contributing to that problem of global warming at that point. It's really important, of course, that every country has a strategy to do that because it's a global problem. It's really important that the UK does something about it. And I think it's particularly important here in the UK that we have every region and community of the UK having its own voice on how to tackle that problem of reducing UK emissions overall, and of course to model for other areas how to do it. So kind of learning by doing. So it's a big challenge to cut emissions. And the other thing that we can do is try to adapt to the changes in climate that are coming. So there's kind of two strategies that we have for climate change. One is to cut those emissions that cause climate change in the first place. And the second is to try and anticipate the effects of climate change and take action to try and minimize the damage that they will cause. There are even possibilities of taking advantage of some of the opportunities that might come from climate change. So we know that well-planned early steps save money. They can even save lives later, and we call that adaptation. So some of the things we can do to adapt, very briefly, we can use water resources more efficiently. We can adapt the building codes that we have so that we're ready for the future weather conditions that we'll have. We can build better flood defenses. That's not just about pouring lots of concrete, it's also through natural means, growing the right trees in the right places so we get better flood defenses, for example. And we can choose things like better forestry practices to make the natural environment, our forests, less vulnerable to storms in the future. These are all really valid things to do in anticipation of the changing climate that we have. And in practice, what we need to do is to reduce emissions and adapt. There aren't really either or things. We need to do both because some of this stuff is, I'm afraid, inevitable. So that's my introduction. You have a very rich set of choices about where to go next with this. I know that Pete's going to help you through that. I hope that was helpful to you there. I'm going to stop there though, and I'll be very happy to have your questions later on.
Okay,